This ICP is all about implementation of information retrieval, TF-IDF, and Voto vector. The main objective of this assignment is to find out the top 10 TF-IDF words from a data set, and also finding out the word to vector similar words for the top 10 TF-IDF words. Uh, Here, coming to the implementation part, basically TF-IDF means term frequency inverse document frequency. TF-IDF weight is commonly used for information retrieval and text mining. Uh, so the main summing the TF-IDF for each query term is one of the most basic ranking functions. The TF-IDF weight is composed by two terms. First one is term frequency. This is the method which measures how a term is repeated in a text, because each document is will be varied in length. For example, a word maybe appear in much more frequently in larger papers than shorter ones. Um, so term frequency can be calculated like number of times term t appears in a document by total number of terms in a document. The next one is inverse document frequency, uh, which means it is a measure for determining the importance of a word. When calculating term frequency, all terms are considered as equal, but in inverse document frequency, some words like is, of, and that can be seen more frequently, but these words have little significance. We need to scale down the common words, and we need to scale up the uncommon ones by calculating this inverse document frequency, like this. Mm, for task 1, we have imported TF-IDF vectorizer from sklearn library to generate the TF-IDF values. And we also imported pandas library and NLTK library. Like this, we have imported all these libraries, and we have defined one function for generating top 10 TF-IDF words from the input. Here we have taken pandas data frame to read the input, um, and we used TF-IDF vectorizer to get the TF-IDF values. And then we have used data frame, pandas data frame, and then we have added one more row that has total to sum the TF-IDF values, and we have sorted out the top 10 TF-IDF values in descending order. Uh, Coming to the next 1A, here we have found the top 10 TF-IDF words for the input using this logic. Uh, Here we have read the input from the text files, and then we have tokenized the words from a sentence and removed the stop words using NLTK library, and appended that read text data to a empty list and passed that list to the defined function, as mentioned above. And coming to the lemmatized task, here is the output for 1A task. And coming to the lemmatized input, here also we have done the same steps, and only thing that varied from task 1 is we have also removed the we have also done the lemmatization, uh, and passed that list to the defined function. Here is the output for the lemmatized words. And then coming to the n-grams, it is a continuous sequence of items from a given text or speech. So n can be any integer. When n value is 2, it can call it as bigram. When n value is 3, it can call it as trigram. We have followed the same steps as mentioned above, and only one one step is we when we are passing that list to the defined function, we have also mentioned the n value as 2. So we are performing the trigram here. This is the here we are passing 2 value to the defined function, and here is the output. From task 2, my partner will continue.
Here we install the basic PySpark libraries. Uh, uh, you can see here, and then we have defined a common function which will help to perform the all the three tasks. So basically it will calculate the TF and IDF values. TF values can be uh, calculated by using the counter vectorized, and the IDF values will be used can be calculated by using IDF. After calculating TF and IDF, and we have added each each feature to the empty list, and then sorted the uh, top 10 highest values. And also we have added a what to vector what to vector in this you can see what to vector finding also we have added in the same function. Then coming to the first task, we have read the given input text files by using the OS module to retrieve the directory, and then appended all the data to the empty list. By using Spark, we have performed tokenization and removed stop words, and the filtered words is passed to the defined function. You can see the output here, showing the um, first one is showing the filtered words versus features, and then the next one is the word to vector values, and also the top 10 TF-IDF words. And next term is n-grams. As my partner explained, n-grams. So the same thing, same thing we have used here. This n-gram has that features can be performed by using n-gram feature in the PySpark, and the n-gram words are passed to the defined function. You can see the output over here showing the n-gram versus features, and the result is nothing but word to vector values. Next task is lemmatization. We don't have lemmatization function in feature in PySpark, so we use NLTK to find the lemmatization, and then the lemma words we send to the defined function. So then we got the features. Filtered words are nothing but the lemma words, and the features output, and then uh, the top 10 lemmatized words are printed, and word to vector are also printed here. In a conclusion note, we have learned about information retrieval, like TF-IDF finding and word to vector. The major challenges we faced here is while calculating the top 10 TF-IDF values using Spark, um, we are getting all the data in the form of a tuple. To extract and compare the top 10, we feel it difficult, but we tried to find out the correct values, but unable to print. We found the values, but it is not exactly matching with the TF-IDF vectorized using a sklearn library. Thank you.